Hello everyone. In this video we're going to be solving a problem from the book Out of the Box Algebra by Dr. KANBIR'S. Dr. KANBIR'S is an associate professor at the University of Wisconsin. He teaches elementary, middle, and secondary school math teachers. In other words, he's a teacher of teachers. So he shared this problem with me and I'm going to share with you. Also check out his other books and I'll share all the links down below. So we have this problem or system. 6 to the power x equals 18 and 12 to the power y equals 3. And we're going to be solving for y. And don't ask why. Let's go ahead and get started. We're going to find the value of y, and we could also find the x obviously. But here's what's going to happen. We're going to find the value of y in terms of x. So we're going to find the relationship between x and y and then use that to isolate y. In other words, make sense? So if you're looking for a numerical value of y, obviously it's gonna be super duper easy. That's not the goal. Okay, let me make that clear and then we can proceed. So I'll be presenting, I think, at least two methods. Let's see how this goes. First method. So for my first method, here's my plan. I want to write everything in prime factorization form. So 6 can be written as 2 times 3. 18 can be written as 2 times 9, which is 2 times 3 squared. And then I have a 12 that can be written as 2 squared times 3. Okay, so I only have 2's and 3's, which is nice. So let's go ahead and replace 6 with 2 times 3, raise it to the power x, and that equals 18, which is 2 times 3 squared. So from here, we're going to get something, right? Let's go ahead and see what happens. 2 to the x, 3 to the x. We distribute the x because that's a product. 2 times 3 squared. Here, my approach generally for these kinds of problems, and I've done similar problems before, you can also check them out, is to put the 2's together and the 3's on the other side. So let's go ahead and see how that works. Let's divide by 2. That's going to give us 2 to the x divided by 2. And let's divide by 3 to the x. And that's going to give us 3 to the second divided by 3 to the x. Make sense? 2's on one side, 3's on the other. So now let's go ahead and subtract. This is first power. So we're going to get 2 to the power x minus 1 equals 3 to the power 2 minus x. So you might be thinking, like, doesn't this give us the value of x? Come on. We could find x right away. We didn't need that. I just want to find the relationship so that I can associate x and y. Make sense? Great. So from here, I'm going to do the following. Let's raise both sides to the power, something so we can isolate one of the numbers. How about isolating the 3? So I want to raise both sides to the power 1 over 2 minus x. And obviously, in this case, x does not equal 2, but you can easily check x does not equal 2 because, as you know, 6 to the second power does not equal 18, right? Hopefully you know that. So x doesn't equal 2, so I can do that. And then here, 2 to the power x minus 1 over 2 minus x on the left. And on the right, these two are going to cancel out, and I'm going to end up with a 3. Great. So I was able to isolate 3. 3 is equal to this. Let's go ahead and do something similar with the second equation. What was the second equation again? It was 12 to the power y equals 3. And 12 will be replaced with 2 squared times 3. And 3 is just 3. Okay, so this is going to give us 2 to the power 2y times 3 to the power y equals 3 to the first power. And then you can go ahead and divide both sides by 3 to the power y. And that's going to give you 3 to the first divided by 3 to the y. And by way of subtracting the exponents, you get 3 to the power 1 minus y. See what I'm getting at? I can do the same thing. Notice that I was able to isolate the 3. Let's do the same thing. So I want to get the 3 by itself. Let's go ahead and raise both sides to the power 1 over 1 minus y. And obviously, y does not equal 1. You know that, right? I mean, come on. 12 to the power 1 does not equal 3. Okay, cool. So this gives us 2 to the power 2y over 1 minus y equals 3. That's another equation I wanted to get. Now let's go ahead and put these two together. What was the first equation? 2 to the power x minus 1 over 2 minus x equals 3, and this equals 3. What does that tell you? If two things are equal to the same thing, then they are equal. Make sense? So from here, we can safely say that 2 to the power 2y over 1 minus y equals 2 to the power x minus 1 over 2 minus x. Because they're both equal to 3. See, I was able to associate x and y, and now I can go ahead and try to solve for y, because our goal is to find y in terms of x. So here's what I can do. Since these numbers are equal and the bases are equal, the exponents must also be equal. Make sense? So this gives us 2y over 1 minus y equals x minus 1 over 2 minus x. Beautiful, right? Now, well, not so nice, but our goal is going to be to find y from here. There's a couple of ways to go, a couple different ways to go about it. You can cross multiply and kind of get a mess, or be a little smarter than this and just flip the fraction. Always look for these kinds of tricks. Algebra is full of tricks. And then you can go ahead and separate this into two fractions. This is going to give us 1/2. I'm not necessarily saying this is the best, but I think it's a little nicer. And add 1/2 to both sides, and you're almost there. Now I got 1 over 2y. Let's go ahead and simplify the right hand side, make a common denominator, multiply by 2, 4 minus 2x, multiply by x minus 1, divide by 2x minus 2. Simplify the numerator, I just couldn't think of the name, negative x plus 3, divide by 2x minus 2, and then flip again. You get 2y equals 2x minus 2 over negative x plus 3. Now divide both sides by 2, and you'll get the answer. And obviously, you don't want to write it like this because there's a negative x at the bottom. Doesn't matter. You can write it like that. Or you can write negative x plus 1 divided by x minus 3. As if this is a little nicer, right? Okay, great. So that's my first approach. And let's go ahead and take a look at an alternative approach for this problem. And that's going to be with logarithms. Okay? So the second method uses logarithms. You got to be careful. And by the way, when I told you that, hey, you can find y right away numerically, this is what I meant. Log both sides with base 12, and you're going to get y. Make sense? So that's not the goal. Make sense? Y is equal to that. So how can I associate x and y? That's going to be a little tricky, and this method may be incomplete. Caution. Okay. Anyways, I'm just going to see how that goes. So here's one thing you can do. You can basically isolate x. Oh, one of the things I can probably do is ln both sides because ln is fun. Let's put the x to the front. X ln 6 is ln 18. And then x is going to be ln 18 over ln 6. Similarly, y will be ln 3 over ln 12. So the idea is, how can I make this from this, right? Because I want to stick to this, keep that. So here's one thing you can do. You can kind of break down the ln 18 over ln 6 into ln 9 plus ln 2 over ln 3 plus ln 2. And then ln 9 is ln 3 squared, so that's going to be 2 ln 3 plus ln 2 over ln 3 plus ln 2. This is x. Okay, what is y? Y is ln 3 over ln 12. That's going to be ln 3 over ln 4, which is 2 ln 2 plus ln 3. So here's the idea. You want to write y in terms of x. So here's what you can do. You can go ahead and find ln 3 over ln 2 from here. By the way, you can divide the top and the bottom by ln 2. And that'll give you a ratio, which you can use here. Make sense? And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.